Hello, everyone.
It's fun to check out.
So the last panel of the summit is cleanup and remediation, where we'll look at some of the efforts and technologies that was developed to tackle the plastic problem. And Jeff Tedmori will be our moderator today, and he will introduce our panelists. So let's welcome all of them.
Thank you. So congratulations, you made it to the last panel of the MIT Water Summit for 2019. We've spent the last few days talking about this massive issue of plastic entering our water streams and entering our ocean. We've heard from scientists, from researchers, from policymakers, investors, and the issue is abundantly clear. There's a ton of plastic, whether we think it's 8 million, 12 million, whatever the metric is, it's obvious that it's way too much. And so our panel this afternoon is really gonna focus on cleanup and remediation and learning about ways that we can start addressing this problem and talk to people that currently are addressing this problem. So a little background on me. I'm a second-year MBA here at MIT. I have made it my personal mission to use business to preserve our world's oceans. Like many of you in the room, I'm drawn to this particular industry because I'm a hobbyist first with regard to the ocean. I'm a fisherman, a diver, a sailor, surfer, whatever you name it. If it's in the water, I'm pretty excited about it. But unfortunately, interacting with the ocean on a daily basis, I've seen the impact, and we've all seen the impact that society has had on it. And so I believe that we really need to do our part to reverse some of that. Little background, used to work for Patagonia on the corporate venture side, so I was investing in early stage startups that really can provide a positive impact to either waste streams, water, food and ag, or material innovation. We made an investment in a company that incentivizes fishermen down in South America to return their fishing nets. This way they can be upcycled back into a nylon 6 and turned into consumer goods like sunglasses, skateboards, and eventually other apparel products. Also helped advise a company called Seabin Project, which has a floating device that attaches onto docks and pilings to capture floating pollution. So without further ado, I'd like to pass it off to our panelists to give introductions. So Susan.
So I'm going to do my whole thing now?
Yes.
Hi, I'm Susie Baer. I'm from San Diego, and I'm the executive director of Clear Blue Sea. Is this loud? Okay. First of all, the last plastic conference I went to was only held by academics during the day. And then at the end of the day, they debriefed the rest of us. And I thought that was not as helpful as this conference, which seems very integrative in terms of the type of people here and what they're interested in, and it's so much more fun. So congrats to MIT for doing that. My background, I grew up in San Diego, went to UC Santa Cruz in the 70s, worked for a while, got married, had kids, got my MBA at Yale, worked in DC, actually, as an EPA consultant. Went to NASA at the Johnson Space Center for 10 years, working with a company called Science Applications. And then I was job transferred to San Diego, where I'd gone to high school, so it was like full circle. In the last 10 years after having corporate jobs my whole life, I became a paid mentor to small business and startups. And then I was asked by SDSU to teach a course called Creativity and Innovation, which I do. And then by happenstance, 3 years ago, I got this nonprofit put in my lap, and I kind of avoided being some kind of CEO my whole life. And now at the age of 66, I'm an executive director and founder of Clear Blue Sea, which, you know, never done before, never done a nonprofit before. So it's been a very interesting 3 years for me. So in San Diego, when we started Clear Blue Sea, we weren't sure exactly what we were going to do, except we wanted to try and figure out different ways of getting plastic out of the ocean. When we were doing our research, we found a lot of organizations in this realm, and many of them are here, are focused on prevention, and others on education and awareness. And it seemed like not very many were really working on remediation. And initially, when we went to go talk to marine scientists at Scripps, we had some negative reactions like, "You're not going to kill a plankton, are you?" Or, "You can't, this is like a stupid project, the money should only go to research." Or, "We don't know enough about it now, so you can't clean it up yet." And we just thought, okay, as we move forward, we want to continue to be in touch with all members of the community, to learn from them what their real concerns are and address them. And we've done that with Scripps and other universities in San Diego. We have over 50 student interns from all the disciplines, and as a nonprofit startup with limited funding, we have used donated materials, donated staff, to get as far as we've gotten. So over the last 50 years, the amount of plastic that's accumulated in the ocean, as we've talked about these last 2 days, has grown enormous. My view is that it'll take 50 years to clean it up, and there's no overnight solution. So I consider what we're doing at Clear Blue Sea to be kind of an innovation exercise. We're not sure we have the best solution. We don't think there is a best solution, actually. We would like 50 sponsored innovations out there, because cleaning up plastic is not just one thing. There's different kinds of plastic in different places, and you can't use the same solution to do all that different kind of work. So we've been reaching out to other organizations that are either interested in remediation themselves or in helping us in some way. And that also has enabled us to progress forward as a small nonprofit ocean conservancy company. So when you're at NASA, you speak in acronyms. And so, of course, I got brainwashed. So when we were, I felt like the robot had to be named. So one night I sat there and I came up with like 50 acronyms and sent it out to my best friends and asked them, which acronym do you like the best? And 100% of them said Fred, so now it's Fred. It's something people seem to remember. Like, oh, how's Fred doing? Like, you know, it's a person or a dog or whatever. And we also wanted to counterbalance it with a female name. So our Mission Control Center is going to be called Remote Operations Services Enterprise. So we have a Rose and a Fred. Or we were going to call it Frederica. Anyway, so Fred is solar powered. It's unmanned. It's semi-autonomous. And it's designed to move at a slow speed to do as little damage as possible. It will have pingers on it that are acoustically sound so that they don't make things worse, but to warn certain animals that it's in proximity. And right now, we've completed 2 6-foot prototypes with the help of many students, and we're working on a 16-footer. After that, we're going to build a 50-footer or several 50-footers and hope to pilot them in Hawaii, because Hawaii has the worst ocean plastic problem of all the states. And then we can prototype Rose, coordinating multiple Freds in operation. And we've talked to people in Hawaii about this. They like the idea of a high-tech Mission Control Center. They've told us, don't bring the garbage here. Okay. So with fleets of Freds out there, when their bins are full, either they will go to a mothership to offload, get preventative maintenance, and go back to work 24/7, Or we're even thinking about a smart storage bin that can automatically detach and then have GPS in its own navigation and own solar, and it can just go find the mothership. We're not sure. There's a lot about our concept of operations we have obviously not finalized. I guess our website is not totally ineffective because we've been contacted by over at least 10 companies that want to buy our plastic. We don't have any plastic to sell yet, but what we've been noticing is more and more companies are trying to, quote, upcycle plastic into usable products. So we write down their name, and in a couple years, we'll be giving them whatever plastic they want. One point I want to make about Fred is that we wanted to do more than one thing. So for education, we'll have cameras on it. We have cameras on the prototypes so that it can be piped in to school classrooms. In San Diego, many years ago, when we had our first panda baby, they put a camera, it was the first time I ever saw this, inside the cage, and it was called the Panda Cam, and we all watched it. And so for the many, many kids in America who never see the ocean, to be able to see what it looks like out there in the wide ocean, we think it would be educational, coupled with the educational materials we provide. The other thing is that we're going to put a version of Fred into the public domain for people to customize for their purposes. We don't want to give them like very strict set of materials or building instructions because we want them to figure out some of it themselves, kind of like IKEA. But it'll be enough they don't have to start from scratch. So in Silicon Valley, we were contacted by a 6th grade class that wanted to build their own Fred, which they are. I just didn't have a nice little pamphlet for them to read and go through a set of phases. But that'll probably come out next, at the first quarter of 2020. Even though we intend to develop Fred and implement it. We think that anyone who wants to implement a Fred around the world should be able to do it, whether it's a river or a bay or an ocean or a coast or whatever. So again, when we made the conscious decision in the beginning, we weren't going to put all our efforts into finding money. My view from helping startups was that when they went to venture capitalists with some great idea and asked for millions of dollars, it rarely worked, and it really shouldn't work because someone has an idea that isn't really good enough, I think, to give them millions of dollars. I felt it was important to have an engineering baseline, meaning that we had working prototypes that we could show people and demonstrate, which we have. So now we're writing grants to fund the 50-footer because we can't build it with donated materials like we have everything else. The other thing about Clear Blue Sea is on our board of directors, on our strategic advisory group, we're almost always 50-50 women, and a lot of women student interns come to us for that reason because they've never worked in an environment that had so many women working in it, which we didn't understand was that important to them, but it turned out it was. And on the board of directors, it's also 50-50, and we're highly diverse in all respects. So when student interns come to Clear Blue Sea to help us on our projects, I put them through boot camp. What does that mean? They have a day of learning about ocean plastic. They have a day about learning about Clear Blue Sea and Fred. They have a day learning about the systems engineering life cycle. They have a day on how to do collaborative teamwork. And the last day, they get a project management tutorial, and they plan the project that they're working on. My view is that, unfortunately, in most business and MBA programs, they don't teach project management. And in engineering departments, maybe MIT's an exception, they rarely teach the whole engineering life cycle, from concept, development, operation, retirement. And that gives a common denomination of information for all the students from 7 different campuses. So when they're together on projects, they have a common framework for working together. So that's basically it. It's just been great to be here. I like the East Coast. You guys have obviously a different mentality. I had fun living in Connecticut, but kind of miss it back here. And I really just want to congratulate all the people here, all the different perspectives that have been shared, and for you guys surviving till the last presentation.
Thank you, Susie.
Yeah.
I'd like to start with a thank you for everyone who came up, and really it's this one person who is responsible for my being here. I'd like to say thank you to Adrian Garcia, who invited me. Your team is awesome. I'm talking about the people who put it together, including Mr. Cameraman and the people behind those colored, yeah, I see you. Okay, can I tell you a story? DNG Pacific is a company I represent. I'm from the Philippines. I've been blessed to work and live in 5 countries. My family lived in 5 countries, and the business that I got into is my 15th business in 15 years, and this is the 16th company where I think I found meaning. So my story starts with, it's not moving. There, okay. This photo is taken in the dump site where it was just a 4-week-old photo. The picture of this girl, the girl over there, is the child of one of our waste pickers. And I was watching her pick up the Phantom of the Opera mask. And she was jumping up and down. I was just staring at her and I said, that can be my daughter or my son. These kids should be in school and they should be doing something more than playing there. So I said, our company's 20 years old and it started when my daughter Katrina over there, please Katrina from Tufts, yeah, I'm proud that she's here. It started on her birthday 20 years ago. But again, remember, 15 years of a lot of trial and error. So this photo is the one that motivates me, and this is the reason why I'm here. I would like to make sure that that people have opportunities and not just us who can be here and learn and play. So the first business that I started when I went back to the Philippines is about cleaning. I started cleaning grease traps, all the dirt, grease traps, floor drains, toilet, all the sticky, grimy dirt. And every time we clean those restaurants, including Shake Shack and McDonald's, we always are left with trash. And that trash and the grease stays in the shop, and we're not supposed to touch it. But I said there has to be a better way of doing it. So from the restaurant business of cleaning the restaurants, we got invited to clean ships for Shell, for Total, for Esso. And we got accredited. And the same story, we cleaned tankers that have 5 million liters in capacity. After cleaning, the captain tells me to get ready because the effluents will be let go in the beaches of the Philippines. And I said, this cannot happen. I have to do something more than just cleaning. Then we moved to poultry and the agricultural business. We now clean 100% of a very nice brand called KFC in the Philippines. We clean all their poultry. So from the cleaning, we also had the burden of finding a way where to put the chicken manure. So I said, that's waste once again. So we found a place to put it. Farmers buy it up north, and it's used as fertilizer after we treat it. And then we got into property waste management. The largest construction company in the Philippines asked us to to clean their buildings that are full of solid waste. So I said, we're not in the business of just collecting your garbage, but we will haul for you, but you have to give me land. We need land so that we can process the garbage and the waste. And then we were given also malls, the big malls in the Philippines. It just continues. The customers just continue to call and ask us to get involved. It's overwhelming. I wish I could bring all of you so you can help me find solutions, because there's not enough solutions for all. So next is waste education and awareness. This is the one that will make our business sustainable. We have to teach, we have to go to community, we have to go back to basics, to teach small kids. So we've contacted the top 3 universities in the Philippines to create a curriculum to teach children, like in Japan, that waste can be handled at the source, which is in their homes. So what you will see here is an actual, this is an island in the south. It's called Palawan. We've been asked to take over their waste management, that whole system, starting January next year. They have their own greenhouse. They have their own piggery. They do not allow any plastics to enter their island. Once you ride their aircraft, you're asked to leave all the plastic inside the aircraft. So over here is, when I did some R&D in Geneva, these are the waste baskets, the waste bins that we will install in the properties where we clean. And underneath here is about 15 feet of, it's like a cylinder. And all the trash will go in there, so you don't see trash on top. But these are all segregated already. Effective waste management solution. What you're looking at right now is 1, 2, 3, 4, 5. These are the most beautiful islands in the Philippines. They've been awarded, from a global standpoint, they've been awarded top 8, top 7 destination in the world. It's called El Nido. They have a very good system of getting the community involved. No plastics, cleanliness systems. Waste is measured. So the approach that has been taken in this island, this beautiful island in Palawan, is for every kilo that is produced by the people in the island, in the stores, they have to pay actually 20 cents. 20 cents. Are the people complaining? Of course they're complaining, but there is really a cost to manage all the waste here. And it was really a challenge. How do we convince a company who is doing well in their sustainability and cleanup in the island? How do we convince them that they should give us the contract to make us involved 100%? And of course, they have to agree on the price. It's a simple calculation. This island contributes almost 20% of the tourism revenues of the entire country. So I said, if that's 20% that you earn from all these islands, what is a percentage that they will accept so that the waste that they produce will be managed well? Because we're talking about water. This is a water summit. We're talking about waste in the ocean, but we are the frontliners. We manage the solid waste. So if we do not do our job of cleaning up from the source, at the source, and all these islands, we will not be able to see these islands as beautiful as they should be. And we will not be able to pass on to the next generations happy faces like this and fishermen who are smiling while they're getting fish. So what we're trying to say is very simple. We need to build the community, and we have that community in the island. The demand for our waste, Asia is very big. So we are a market. We invite those people here inside this room. If you want to come over and share your brilliance and your ideas, we accept trainees during summer, and that's what we have. it is the market, it is the laboratory where you can really make yourselves useful. We prioritize solid waste because before we can even touch the waste in the sea, we have to go to the basic, which is solid waste. What we'd like to do is to prevent everything that becomes a big problem. It will have to be prevented from our end. So our call to action really is to be very serious about putting the minds together, industries crossing over. For example, my friend in Hong Kong who asked help to start a business in the Philippines, they are such a dynamic group. Their client in Hong Kong is Cathay Pacific, and they were able to convince CX and Delta to put together their food waste, turn it into biomass. So the first aircraft that flew from Hong Kong to the US flew in October using the food waste. Using the food waste. So the point is, there is no barrier into industries, there's no barrier into countries. Another example, IKEA went to us and said, we heard you're building a factory of solid waste, a segregation factory. Can you please commit to us 100 tons of cartons? And I said, we're not yet there, but we want to be there. Okay, once you're ready, please make sure that you can supply us 100 tons because we need that to build our furniture and our stuff. And guess what? The local Gap, they're called Bio in the Philippines. They've approached us because they have 5 tons of clothing materials that they don't have use for anymore. So when they gave us the 5 tons of materials, clothing materials, we gave them to IKEA, of course, for a price. And that's how I think we should do things. We should put our minds together. Industries, people, countries are no longer barriers. So this is my last slide. These, again, are children of our waste pickers. They are our heroes. And I always tell my kids, you are going to very good schools, and we live a certain lifestyle. But these kids, I mean, their parents are the ones that are doing the dirty jobs of having to face all the grime and the smell, everything dirty. So our responsibility as a company is to make sure that these kids are provided education. So when we do this, this is a whole circle of helping each other. No matter how much technology or science or solutions we have, it has to be the person and the community who will put together the solution so that we can help make our country even better. So that ends my presentation.
Thank you, Edmund. Neel.
How was that? That's beautiful. Thank you.
Great. So, hello, my name is Neel Joshi. I'm a faculty member at the Wyss Institute for Biologically Inspired Engineering and also Harvard School of Engineering and Applied Sciences. And thanks to the organizers for inviting me here. When I first got this invitation, I was still puzzled as to how what we do really aligns with a lot of what is been talked about here. And over the course of today, there have been some eye-opening kind of things that I've learned, because water and ocean plastics is not directly my field, but we do work on making materials in a completely new way, I think, that could play a role potentially in what we want to do. And so just to kind of set this up, the thing that my lab is interested in doing is building materials in a way that biology builds them. So if you think about like a tree that grows from a seed, that seed has a bunch of instructions embedded in it to grow into a tree, and it does that by assimilating nutrients from and water and sunlight and other things from its surroundings, and grows up into this functional, mature material. And even after it's fully grown, there are cells embedded in the tree that can allow it to respond to its environment, play certain roles, et cetera. And so my lab is interested in making materials from a manufacturing perspective, but in a similar way where we genetically engineer cells, especially microbes, to build structures in a similar way. And so let's see if I can get the slide to advance. This is one of this is a kind of a technology platform that my lab has developed in order to address some of this. And I know I want to say up front that I'm not saying that any of this is an immediate and direct solution to a lot of the plastic pollution and management problems that have been discussed today. And in fact, in the posters outside, there's already other examples of different approaches to this. But I think this is something that can contribute to the types of technologies that we might be able to benefit from in thinking about how we make materials that can avoid the types of problems that we heard about earlier today. And so the way this works, and I'll try to describe this so that everybody can understand, is that we've engineered this microbe. We use a pretty standard non-pathogenic laboratory strain of E. coli. So this is a bacterium that is probably the best studied organism in the world ever. And it's also already used in manufacturing contexts. So what we did is genetically program it to make a bunch of polymers by secreting proteins outside of the cell. Those proteins, once they get outside the cell, they start to assemble into these fibers. And then those fibers, we can have a lot of control over what those fibers do, what their properties are, based on genetic engineering that we apply at the start of this process. And so after the cells do this, they assemble this material, we're able to make effectively like an engineered biofilm that contains cells and the fibers that they made, and that is pretty close to a functional material in terms of what it can do. It functions like a macroscopic film in some cases, and I'll show you an example of that in a second. But overall, we see this as a potentially scalable manufacturing paradigm that is has some unique features that distinguish it from other forms of bioplastics. So there are some really nice examples of bioplastics that have already been discussed here. Like I said, there's some posters out there as well. And those typically use either polyesters or other plant-derived polymers. And those are great in many respects. They're abundant. They can have a kind of carbon neutral life cycle. But one area where they might not be sufficient for certain applications is that you're stuck with a certain polymer that is made by nature, right? Trees grow and, or agricultural crops grow, and they are made up of certain polymers. We can do very little to change what those polymers are, right? You can't make corn change into some completely different thing that's made of a different polymer other than cellulose. Similarly, bioplastics that are used in compostable bags and other products like that are made up of a very narrow set of polyesters that have some properties that might not be amenable to all these applications. What we have here is something that we can have a lot more control over the types of polymers that we're producing based on the genetic programming that we're able to do. And so just to describe an example of what one might be able to do with this, we have a project where we try to simplify kind of a simulated manufacturing protocol as much as possible, where we just grow these bacteria in a flask, as is shown there. We put that biomass after it's grown, and we've induced the formation of these polymers, these protein fibers that we've made. We filter them, so they're caught on the surface of the filter. And the thing that we do with this is allows us to achieve properties that kind of surpass what you might be able to do with other types of bioplastics, is we genetically engineer these bugs, these bacteria, to produce these fibers in such a way that they are displaying, so each unit on it, these little red cups that are displayed all over the surface of these fibers, have a specific affinity. They're able to bind to lanthanides, rare earth metals, very tightly. Okay, and selectively. So they ignore all other metals, and they bind selectively to these lanthanide metals, which are components of e-waste that people who might be interested in recycling they need new ways to kind of selectively concentrate those so that they can be recycled, et cetera. And so by doing this, we give these fibers that we make a specific property that biology and protein-based fibers enable that is difficult to achieve with other more conventional bioplastics. And so what we were able to do is take mixtures of metals that have these lanthanides, the rare earth metals in them, but also have other metals in much higher concentrations. So these lanthanides are sometimes called rare earth metals. They're typically found in much lower abundance in geological samples or even mine tailings or recycling streams compared to other more abundant metals. And so we simulated a recycling stream by putting other metals in there, aluminum, calcium, copper, like you see up there, in much higher concentrations than the lanthanides themselves. And then we put that mixture through this filter. And then what we want to see is whether we can pull out the lanthanides selectively and ignore everything else. And so that's indeed what we were able to show, is that we were able to pull out the lanthanides selectively only when we engineer these fibers in a specific way. So those are the red bars up here, and all of these are the lanthanides. The lanthanides are the metals that are at the bottom rows of the periodic table, typically hanging off the bottom there. And then the orange bars are if we don't engineer the fibers, then it shows that you don't bind any of these lanthanides. They just go straight through the filter. They aren't retained. And so by virtue of our ability to specifically engineer certain capabilities into these fibers, we can pull out these lanthanides selectively, and then we can also recover them. So if we do a dilute acid wash, we can basically recover all of these lanthanides from the surface of the filter and then reuse it. So this is a way to biologically manufacture a material that has a relatively complex function compared to a normal filtration membrane. And I think things like this maybe could be applied to making filters that can, for example, be even better at removing microplastics than existing filters. They can do it in a passive way, possibly with lower energy input, et cetera. So in addition to these types of materials, other things that we can do are make actual macroscopic 3D objects that could function like bioplastics. And so this is the kind of protocol that I showed you before, where we're just filtering biomass. We can apply certain washes to that to retain certain aspects of this biomass and get rid of other aspects. And then this is what a microscopic view of this filter membrane looks like, where all of this material is essentially composed of that single protein that I showed you. And then we can process that just with this simple filtration into various different types of objects, materials that function like bioplastics. And so based on the genetic engineering that we do all the way at the beginning of this process, we can create things that are either flexible or that are rigid, especially if we combine these fibers with other renewable sources of raw materials like chitin. And so we have a lot of control over the types of material properties that can stem out of this approach. And this is very early stage work in my lab, but we are kind of working on making things that have properties that could actually function in packaging. And one of the major advantages of this approach is that all of this is completely biodegradable, and so it wouldn't be able to accumulate in oceans, for example. And I think in this panel, we'll probably get into the relative trade-offs of having biodegradable things versus things that are retained, because it's not a silver bullet or a magic bullet, I guess, in terms of solving our problems from a plastic pollution and climate change perspective. There are certain trade-offs which I think we can get into later. But that's an example of what we do in my lab, which is just one example within a larger, I think, research ecosystem of new ways of thinking about manufacturing.
Thank you, Neel.
Who has lost property or had something ruined in a storm or a weather event? Flood, hurricane, anything like that? Not so many people. A few. This morning I talked mostly about our solutions as they related to microplastic, but I'm going to take just my short amount of time to talk about something that hasn't been talked about very much over the last 2 days, or two items. So one has to do with weather events and the creation of incredible amounts of marine debris because of things like hurricanes, earthquakes, even just big rainstorms that happen suddenly in cities like Boston, especially in the Northeast, or Miami. Our experience with this from a data perspective comes from the aftermath of Hurricane Irene in Vermont. It kind of wasn't supposed to go down like it did. We didn't get that much wind, but we got flash flooding. And I live in the center of the state, where I was a valley connected by roads to the north, south, and west, and all of them washed out. I became an island in the middle of the state of Vermont. And that happened in a lot of places. A lot of homes were washed away, an incredible amount of damage was done. And the result of that damage, the physical component of that, was trash that got washed down rivers and ended up all over the place. And so Rozalia Project teamed up with the Department of Labor, the Vermont Department of Labor, through money from FEMA to clean public spaces, public areas in these flood zones in Vermont. And what we did is we put people who lost their homes or jobs because of the flooding back to work in a paid position. We had 6 months to do it. In the end, we had 41 people take advantage of the program and help us do this. We had 6 crews in sort of 6 regions around the sort of middle airing west of Vermont. And together they picked up over 500,000 pieces of trash. And I wanted just to share a couple interesting things. One is this. There was a guy somewhere near Montpelier who had a car repair business in his home. He had been essentially stockpiling tires or just not dealing with them. He had been given a citation by the county or the city to get rid of the tires. He didn't. And Hurricane Irene took care of his problem by washing all of the tires off of his property down the river where they were kind of deposited with all of this other stuff. This is really just, it looks like organic matter in the photo, but it's mostly broken household things, a lot of plastic. And our crew, our Waterbury crew, picked up over 2,300 tires that cost $2 each to get put on a truck and sent to Maine, which is the closest place to recycle them. It's just a little trivia. Fish, the band with a P, their Water Wheel Foundation paid for the recycling of those tires. Ben & Jerry's also helped pay for the removal of the trash. One other thing about this project was that we had one guy on one of the crews very, very interested in microplastic, and through him we learned that there are thousands, we don't know the number, but he was able to alone pick out thousands of resin pellets. So resin pellets are pre-consumer. They're they're this before it became this. They're the raw material for plastic manufacturing. It turns out they're all over Lake Champlain's shores. So that's kicked off a little research project for us. We're trying to figure out where they came from and if they're a legacy problem or if they're still happening. So my point here is that the result of weather events is something that we as communities will have to address, and that is a support, that's speaking in support for cleanup programs that are efficient. Okay, so anyone been diving in Newport, Rhode Island, the harbor? Not a lot of people go diving in their urban harbors. That's where we do most of our work. If you saw my talk this morning, you met Hector the Collector, our ROV. And this video was taken through the eyes of Hector the Collector. This is in the northeast corner of Newport, Rhode Island's harbor. And just keep watching. Tell me when you see something specific that you recognize. You can shout it out when you see things that you recognize. Plastic cups, cans, there's a koozie. Plastic. Bottles. Yeah, there's some bait bags stuck in there, but mostly what would you say you see, what's the majority?
Cans.
Yeah, single-use plastic, mostly plastic cups of all different types. We just passed that turned out to be a Red Sox hat. we did clean this up. A little bit with the ROV, clearly not the most efficient way to clean the ocean with a set of grippers that are this big. We did eventually team up. It was good practice for piloting. We teamed up with some divers to clean this up. So we call this the underwater trash heap. The reason I'm showing it to you is something that really hasn't come up over the last 2 days is the lack of information we have about the marine debris that isn't where we can get it on the shoreline or broken up into microplastic or large chunks on the surface. there is likely an incredible amount of marine debris that is on the sea floor. It could be right under our toes like this, literally standing on a dock. It was right in front of the Newport Harbor Hotel and Marina, and in 10 feet of water, it was right there. Now, interestingly, we could see a lot of the source of this stuff by lifting our heads up from the ROV controls and looking at the restaurants and bars that were right on the water with their plastic cups all over all the tables and on the bar. Now, I know there's a bunch of sailors in the room. So we're in the northeast corner of the harbor. Does anyone know where the sea breeze comes from in Newport? It's a southwesterly sea breeze. So this was the downwind catchment for the dominant breeze in the summer, at least in Newport. And for me, it was kind of the perfect storm location version of the perfect storm to have this happen. This is not what all of Newport Harbor looks like. In fact, it was about 10 by 15 feet in size, this heap. The thing that's interesting, in addition to its very existence, is the magnitude of the amount of trash we found in a concentration that rivals that of the trash found in some of the accumulation zones in our oceans. And so my point here is also for people working on this problem, especially those of you interested in the underwater part of it, or just remediation or prevention, is to think about the underwater side too. It is arguably even harder to pick it up from underwater than it is to get it off the surface. There's lots of issues with visibility, safety, silt, habitat. I mean, it's clearly not good for the habitat like it is, but just vacuuming it up doesn't feel right to me. So this is a problem that needs some attention. And I'm just gonna wrap this up, this little bit, with a reminder that, of course, along with the cleanup part of remediation, the front end is so important. And whether that front end is extremely front end, which is prevention through education, there's been a fair amount of, I think, consensus in the importance of inspiring all generations as it relates to facts related to marine debris and what we can do to prevent it on a lot of ways, but then also interventions that can come between, we'll say, prevention and needing to clean it up. So with that, I really appreciate the opportunity to have spoken today, to have been here all weekend, and I look forward to the discussion.
Thank you, Rachel, and thank you to the rest of the panelists for giving that introduction. So obviously, the effort that's needed to clean up this particular issue is astronomical. It's extremely difficult. And so my opening question to the panelists are, what are some of the biggest challenges that you have with implementing some of these cleanup efforts and remediation, whether that's on land waste management or in the ocean?
Want me to start?
Sure.
So I think the biggest challenge is political will. In the United States, for the marine debris program, it's probably funded way less than $50 million a year. Compare that to Indonesia, where a few years ago they decided to allocate $1 billion to ocean plastic cleanup. Why? Because they had political will to do it. Also had some economic concerns that had to be addressed. But still, I think our biggest challenge is political will. Because all the technology we need to start learning how to clean it up, to expand our research on what's out there, it's already here. There's nothing new on FRED. We're just integrating existing technology, but there's no political will. So that's why Clear Blue Sea, even though we're focused on building our robots, we go to K through 12 classes whenever asked to provide as much educational awareness as we can.
I'd like to build on what Susan just mentioned. Yes, I believe it's political will. Number two, for our country in the Philippines, logistics is just so expensive. We have 7,100 islands, so you can imagine that moving stuff from one place to another is a nightmare. Cost is very high, and that's why the direction of our company is to deal with private companies. So when we deal with private companies, we are asking them to, of course, fund their services, the services that we provide. And by doing that, we put together these big companies, like Coca-Cola has approached us, and they've asked us to clear up all the PET bottles of one mall. And the first thing I said was, if we are going to go to you, you will have to make sure that aside from time, you will have to put a budget, because we cannot just pick it up for free. They were asking us to bring it to them for free. And I said, there's cost, we cannot afford that. So when we work with big companies and they have the marketing arm, they have the voice, they will be the ones to communicate to the community, to the people, that it can be done from their side. And hopefully, when we do that, the government will actually support us too. Because the truth is, this will only be successful if we put the private sector and the government together.
I think one of the biggest challenges, it's related to what you guys just said, has to do with the fact that what we're cleaning up has so little value. And that if what we're picking up can, like Dr. Sanchez said yesterday, be designed with value in mind on the back end, then there's potential for political will. The economics start to work out as what would be a traditional business. And that right now is very difficult because there's a lot of proprietary plastics being used that can't even be recycled. If virgin plastics are extremely inexpensive and recycled plastics are expensive, that's difficult. And then that's when you have a lot of it. And then you have the little stuff, like think about kind of microplastics. That's something we think about a lot. And microfiber, we've got this thing that catches microfiber. And one of the most frequently asked questions we have is, what do you do with the microfiber? I'm sitting there with like a fuzzball of my microfiber. What do I do? And unfortunately, right now, you need to throw it away just like you do your dryer lint. It's all the same stuff. Unless you wear 100% organic down to the dyes, 100%. Which is very difficult, then you could compost it. Otherwise, and so some of the challenges there are, I can give you two specific examples. One of the Sea Education Association tows in the northern Atlantic, they went out, they got 40,000 pieces of microplastic in one Newstown tow, and it weighed 4 pounds. And it was all, God only knows the number of different materials it was. So there's a volume problem there. With the microfiber, I've been looking really hard. We've been working really hard to figure out, can we upcycle this? I know that's unrealistic. If so little is being recycled, who's going to drive their fuzzballs from their laundry around? But still, as an exercise. And what we learned is that we found someone who said, we can take laundry lint, all of it, dryer, whatever, if it's 80% polyester. Now that's cool. They could take 20% dirty feedstock. However, there's no technology that could scan any of this stuff and say, that's 80%, send it off. Or there's no technology that could separate it. So there's some challenges there.
If I could just add one thing, you said little value. And I think that's how we think of it now. But in Indonesia, they did some science and they found that if they incorporated into their new roads 10% plastic, it was more durable without fragmenting, like over 10. So in that respect, it has value. And I don't think we understand yet the potential value. I mean, I think we're gonna find that out over the decades to come. And so I think it's really important for people to keep open, imaginative, innovative brains about how, we can not only most effectively remediate, but how can we repurpose? So I think they have a good example in Europe, does bike paths with some plastic. And maybe that's not the right answer, just like margarine turned out to not be the right answer as a replacement for butter. But it's good to innovate and find out what happens.
Speaking of that, oh, sorry.
Oh, well, I was going to say I can only speak from a kind of academic research perspective. That's where I come from. But like many things, research is driven by funding. And I think there is a bit of an imbalance in terms of the urgency with which we need to solve some of these problems and the focus areas of funding that exists in our country. So, and that there's also an imbalance in terms of the power structure a bit of who makes the decisions about where this funding goes and what the interests of people kind of in the trenches is. So, you know, if I go to federal funding agencies to develop a new type of biodegradable bioplastic that is not always viewed as the sexiest, coolest research project, whereas I also was a faculty advisor for an iGEM team. So this is an undergraduate genetic engineering competition where it's all supposed to be very kind of grassroots, organized by students themselves. And there's a ton of interest for tackling these problems. And so there's trying to see how we can get this interest to be reflected in the types of projects that are funded, I think is a big challenge.
So Neel, speaking of value, the 2 days that I've been here, one of the biggest things that happened is I met, aside from Rachael, Cindy, who's put together waste from the sea. She puts value by creating products that are so pretty, they're so creative, and aside from putting together something that's not just expensive but beautiful, that can be sold for a good price, and that's where we become creative by funding all of our efforts in trying to do the cleanup. So again, there's just a lot of creativity that has to be pulled out of our brains, and the more we talk about it, the more I speak to the people who came here. There's one thing that is really resonating. People like when people volunteer, the volunteers just get together. They have the right disposition and the heart, so you come up with solutions like the beautiful solution of Cindy.
So I keep hearing the word funding, right? So when it comes to a solution like this, somebody has to pay for it, whether it's the public sector, the private sector, through grants. For the work that each of you are doing, how do you, where does the funding come from for these type of projects?
So I think there's two main sources. One is they're calculating more and more the cost of not doing anything, whether it's the loss of money from tourism or shipping or fishing or whatever it may be. And so as an econ major, you know, if we're losing 15 billion or whatever the number is every year, and some solutions help reduce that by half, it only costs $1 billion, then that's a leveraging point. You still have to educate people about that. So I think the one funding source is industry. Actually, it's more than two. But like in the case of Fred's, if we wanted to make it commercial, which we may end up making parts of it, to have a lot of robots out into the ocean where it's very expensive for humans to go now and collect lots and lots of scientific data and research samples, air, plastic, water, whatever, that has value to the world. People sell data and samples, and even like through NASA, we would sell payload space on station and shuttle for various organizations to do their research. And on top of that, there's lots of UAVs more and more prevalent in the ocean, and they run on batteries. So when the batteries run out, those UAVs have to go back to land to get recharged. Well, when you got 100-foot Freds out there that have lots of extra energy, they're almost like floating electric charging stations, all of which has commercial value. So, so at Clear Blue Sea, we want to be self-sustaining financially. We're not really interested in making a lot of money, obviously, because we're a nonprofit. And then when you look at the federal budget and percentages that go to different agencies and different programs, that reflects our values. And what I tell my students is, when you guys get into Congress, like AOC, you could decide that $100 billion is going to climate change. You could decide $50 billion is going to go to environmental cleanup. You could decide. But if, like you young people here, you're a source of funding, okay, for in the future when decisions are made about how our federal tax dollars are going to be spent. And most of you young people may not realize that quite yet, but hopefully that will become more apparent as your lives unfold.
One of the obstacles that I've run into when I was working overseas in Australia with this company called Seabin, I would basically go to docks up and down the eastern coast of Australia, and I would talk to these old, crusty marina owners and try to convince them that they need to buy this product to help clean up the water. And the issue that I found time and time again was, that's not my trash, right? As soon as it's in the water and it's not on my dock anymore, that's not mine. Why should I clean it up? As soon as the wind changes direction, it's gonna go to that guy's dock. And so I find a difficulty for anybody to take ownership of it once it does reach the water.
Hopefully that's a generational thing, and dinosaurs like us will die off, and the more enlightened millennials will make better decisions. I mean, that's the hope for the planet.
Yeah, I hope so as well. And Neel, you touched on it just lightly when you were giving your presentation, but can you talk a little bit about the difference within these polymers, the difference between like what is a bioplastic, what is a biodegradable bioplastic as you're talking about, and what are the different implications that come there when they enter the marine environment?
Yeah, so I think the vast majority of the types of plastic materials that we've been discussing in terms of ocean pollution are sourced from fossil fuels, so they come from petroleum byproducts, essentially. I think off the top of my head, about like a tenth of a barrel of oil that comes out of the ground goes towards fabricating plastics, and so those are, that's their source, and then they end up being non-degradable, right? So they don't break down based on natural biological actions. And so that is, in one sense, the source of a lot of these problems. And then there are other ways of thinking about this. You can use on both ends of this, because you have to close the loop, right? So having things that are produced from renewable sources that are also biodegradable, or close the loop in some other way through recycling is going to be important. And I think all of those things need to be attacked simultaneously in order for things to get better going forward, because any one of them alone is probably insufficient. We have a ton of pollution already in the ocean that somebody needs to do something with it, or we all need to do something with it. We have a lot more plastic that is going to be made. It's slated to be made. Somebody earlier in the day had a chart of the projected plastic manufacturing up to 2050 or something like that. And I think it said that about 30%, 28%, something like that, of the plastic that is going to be made over this period has already been made, which means that 75% has not even been made yet, right? And so clearly we want to avoid that stuff having to make that, or to have alternatives that aren't going to lead to the same problems. And so, yeah, so these different factors, different ways of making materials, different ways of closing these loops, I think all need to be attacked.
Rachael, I think you have a really interesting perspective working both with the Rozalia project as well as with the Coraball. Can you talk a little bit about how some of these cleanup and remediation efforts, how they differ between a for-profit and a non-profit entity?
Yeah, that's been really fascinating. And yeah, so, with Coraball, So there's a couple things that I suppose I could say about this. So one is I started out with Rozalia Project presenting and teaching. So we started 10 years ago. October 21st was our 10-year anniversary. And there weren't a ton of people talking about trash. In fact, people weren't that excited to talk about trash, not like they are now. It's awesome now. So I spent a lot of time in the beginning what I would call teaching. And then it was interesting, I realized that we had to evolve a little bit and needed to do some inspiring. So that was a kind of phase 2. And then as we developed the Korabal, we had to learn to do pitching. So that was another sort of skill, a communication skill. And now I try to exist, depending on who I'm talking to and what's going on, sort of somewhere in between all of those, with a little heavy on the inspiration is the goal. And thinking about some of the funding issues related to the two organizations, as you were talking before, I was thinking, with Rozalia Project, we've also had some evolution, but I could say, in general, our cleanups are generally funded by corporate partners. Our programs, education programs, are generally funded by foundation partners. And our general operating, which is so critical, is generally funded by individual donors who are happy to support us in a sort of entirety. That's a pretty typical suite of funding sources for nonprofit. For Korabal, the way we made that happen is it was inside Rozalia Project, and we got a grant for R&D. That was a Family Foundation grant from Schmidt Marine Technology Partners, and then some great help in a couple different accelerator programs. We then did a Kickstarter campaign, which would really not be something that most nonprofits use, so not really available in the nonprofit world. And I'd only recommend that when you're feeling very hearty and ready. So we had the Kickstarter campaign to really launch the for-profit side, and we've been bootstrapping it ever since, but using in the blackness that we've had, which is not wild, but it's there, to support Rozalia Project back. So we're working on kind of making sure that they're supporting each other in a lot of ways.
It's helpful to understand the financial stability that's really fundamental when working with a lot of these NGOs, because Susie, as I'm sure like you can attest to, having to write grants on an annual basis, it takes a lot of time. It takes human capital to spend the time writing these things.
Well, one thing I want to say is that as someone who was writing federal grants for 30 years, to me that's not the hard part. And I feel like I need to change my way of thinking, because the funding that we've received from philanthropic organizations, we never applied for. So it's like, it's weird when you get a check in the mail you never asked for, but it's kind of great. And whereas some of the grants we've applied for, because we're not viral, and don't have national recognition, we don't get funded that way. So I'm trying to sort of figure out, how can I get more grant money that I don't apply for? And that is a harder problem that's a different problem than I'm used to trying to solve. But I think that there's something there. Just don't know what it quite is yet, but I'm gonna try to figure that out as a source of funding.
Will you share that data when you get it?
Yes.
Edmund, I have a question for you. So
Yes.
As we look to create some of these innovations that help to clean up this issue of plastics in the ocean, a difficulty that I always have is finding a way to measure success. And one of the things that we do, or that we've done, in my experience, is we compare the cost of cleaning up the ocean to the cost of on-land waste management, right, which is, it's tough because it's obviously a lot more efficient to clean up waste that's on land. But can you talk a little bit about what type of metrics you look at in the Philippines when you're dealing with waste management?
Okay, we measure in tonnage, daily input. So when we clean and we collect, we make sure that the equipment that will process that will process the solid waste will be processed properly. So it's compost, it's recyclable, recycle, upcycle, and hopefully energy. So how do we measure success? We measure success by having a low inventory of output products. For example, the compost. We generate 40 tons of chicken manure for 40 houses, 8 cycles a year. So that's about 6 million tons of chicken manure. So our success is to make sure that that 6 million chicken manure does not stay inside the warehouse. It has to be moved out so that it is used by farmers in a very good way. For solid waste, we make sure that that solid waste will be transformed into compost or whatever. And we don't like seeing that inventory in our warehouse because that kind of waste is just eating up space. And in the eyes of the property developers, which we got as a client, they won't give us space. So we value very much the space that we have. So today, our measurement of success is that turnover. The other measurement of success is, again, very personal. When we count the number of people who are in part of the company, DNG Pacific, we immediately count the number of kids or family members there are. So if we have an X amount of people, we look at how many of them can we provide education for because of the efficiency that we're putting together. So those are my 2 answers.
Got it.
Yeah.
Yeah, I'm not gonna lie, if chicken manure was my inventory, I think I'd be trying to turn that over as quickly as possible as well. Okay, so one final question for the panel before we open it up to Q&A. Just quickly, what opportunities do you see that are out there that currently aren't being addressed with regard to cleanup and remediation?
Oh, well, that's why we want to put Fred in the public domain, because I think a lot of high schoolers can certainly make a Fred, maybe even 6th graders are trying to, college kids definitely could. But they don't know they can make them, and they don't know there's a benefit for making something like that. Or maybe it inspires them to create something else that's more useful. And so I think, an unused opportunity are the younger generations that are not being given a chance to actually innovate in their own lives because they're not taught innovation and they're not given the opportunity. In San Diego, another organization called Ocean Discovery Institute was created about 15 years ago in one of the poorest school districts in San Diego. And these are kids who've never been to the ocean or never go to college. And they rotate 2nd and 5th graders through ODI so they learn how to do science. And one of our Fred prototypes is there, and when they learn about ocean plastic and what Fred can do, then they're given Lego type things to build their own Freds. Well, we could be doing that in all the school districts, right? And I think of it as being a really shining example, and it's an opportunity that's not being leveraged practically everywhere else in the United States. But at least it's innovating something that's been successful and is a model.
Some of the opportunities, so thinking about this, I have 2 specific opportunities. In cleanup, I think there's opportunity to develop systems that help, again, retain the value of what's picked up. So some kind of cleaning, decontamination technology or process. Right now, there's a lot that we pick up, this sort of just this ocean trash that ultimately can't get anything but landfill or maybe waste to energy, but if there's that might be an opportunity there. And then the other is in science enabling technologies, especially sensors, to take some of the contamination issues away, especially as it relates to microplastic, and developing really robust nearshore modeling capabilities to understand what's happening and where we should focus effort.
The opportunity that I see is to create platforms like this in our country, because this is a powerful group. Because of technology, we can come together and not even be worried that you're in Vermont and Cindy's in New York. We can put together our minds, get this thing moving. Because I was just telling Adrian a while ago that while I'm here in Boston, my friends from the region, from Asia, just kept on sending invites, because there's this guy in Shanghai who used to work for DHL. He started like a movement just by putting together YouTube videos of people like us. And all of a sudden, I see my face on YouTube, and I tell my kids, I didn't know that it's going to happen, but these are the things that I believe can help move things forward. And why do I say this? Because the guy from Indonesia wants to see the guy from Bangkok, and the guy from Bangkok invited me to see him, and the guy in Vietnam said, let's go to Shanghai, and the Shanghai guy goes, let's go to Japan. So all of a sudden, a network has been created, and I believe if you have like maybe somebody like Jeff, if that's the type of thing that you want to do, or you have some friends who want to put that together, it's going to be powerful. And we don't need to be limited with the resources that we have in our own location.
Yeah, so I think an opportunity, I think other people on this panel and other people who spoke earlier really emphasized things like waste management, cleanup, and so I'll take an opportunity to emphasize changes in manufacturing practices. So that's certainly something that we're interested in. Biomanufacturing is already being seen, being commercially translated in many respects to not yet to create things like plastics, but some of the things that you interact with on a daily basis, your vitamins and fragrances and stuff like that, are not made from crushed up roses or leaves, et cetera. Now they're made from fermentation. And so the opportunity to make better materials that fit in with our goals for reducing plastic pollution, having circular economies, I think hopefully the tide can shift to incorporate that into that aspect of biomanufacturing as well. I mean, we as a humanity didn't vote on using plastics, having plastics be the foundation of our economy, right? We adopted it because it was available, because it was convenient, because we could make things out of it. And so now that we have better technologies potentially, and those that are being developed, there's an opportunity to change that. And the grand vision, I guess, is that all of the stuff that we heard about today, initiatives that start with consumers and municipalities banning single-use plastics, creates a playing field where it is more convenient and profitable to do things that benefit us and the environment. And so, yeah, I think biomanufacturing has a role to play in that as well.
Definitely. Yeah, we didn't have the option to vote for whether or not plastics were going to exist in this world, but I believe that we now have the option to vote with our wallet when it comes to the purchasing decisions that we make, the retailers we choose to work with, and even an event like this, like Adrian trying to put on this entire water summit with his team, made an effort to make it a plastic-free event. That's something that, as a conference, it's so much easier to not have to have an argument with your caterer when you're trying to tell them they can't use plastic on anything. But taking that extra step and choosing one caterer over another because they're open to using compostable cups and not using plastic is the next step towards showing the market what the consumers are really demanding.
Not just voting with your wallet, but voting with your vote and with your effort, educational efforts, and putting together symposia or whatever it's going to be. Yeah.
Absolutely. So at this point, I'd like to open up to the audience for Q&A. We have mics on both sides, so feel free to ask away. Thank you, Adrian.
Everybody's tired.
Yeah,
All right, I'm the most excited one for this to be over soon. But I know you kind of brought this up in one of the questions, but I wanted to maybe spread the question to all of you. What has been one of the, or some of the biggest successes that you've had in terms of cleanup and remediation? That, what are the things that keep you going? It sometimes feels like, especially these past 2 days of doom and gloom, talking about plastic, basically covering our planet, inside us, and our water. What do you consider some of the biggest successes that, sort of continue to motivate you and say, this is the fight worth fighting?
Yeah, what keeps you going? What's that one success story that's sort of emblematic of why you're fighting this fight?
So for us, it's very small, being a small nonprofit startup. But when we did, we tested in Mission Bay, one of our 6-foot Freds, and we didn't want to leave any plastic there, so we had ping pong balls in the water. And it happened that there were like a summer camp of kids. And some of the people put out a press release. I don't even know what a press release is. And 4 local TV stations came. And when they came, I had them interview the students who had helped build the robot versus the boring adults. But all the little kids were so fascinated by Fred. And then to see them on TV while these reporters were trying to explain what it was. One of them called it a contraption, but that's okay. It was very great positive feedback for our student interns, who for the most part are just getting academic credit and not being paid. And just for them to see themselves on TV helping to communicate awareness was really great, but baby steps.
Something that comes to mind with this question, thank you for this question. So we've chosen to do our work from a boat, which means owning a sailboat, which that's kind of a stressful thing sometimes. However, it is also the source of some of my greatest joy, and with the people that we've put on the boat, the people that have come with us. And I can say that there are 3 people that, thanks to the work that they've done with Rozalia Project, have gotten their dream jobs. That's their own words. That's as one person who's one of the coordinators for Ocean Conservancy's Trash Free Seas program. But they're all 3 in ocean protection. And I find that very satisfying and inspiring. I have 2 alumni in the room. I love that. And hopefully maybe in the future some of you.
Okay, I go back to 15 years of business, doing business in 15 years, 15 businesses. That was a failure. This is the 16th business I got into. And this business started with the same way the 6 people I spoke to in this summit. We all started helping out foundations. We all started out giving. And when we started giving, the return is just tremendous. The friendship, it's a lot of satisfaction. But simply put, because we're in the business of integrated ecological waste management, we really felt like, well, I felt like trash after 15 years of 15 businesses. And I just felt like I was garbage, useless. And then I hit rock bottom. And when I hit rock bottom, I was transformed, so now I'm transforming trash to treasure. So that's the business that I got into, and that's what happened to my life, which is why I can smile in front of you. And really, this is such a great event that I am volunteering to be here next year, even just to attend. Because this is a milestone for myself, for the family, even for the business. I call my staff, there's 230 in the payroll. I always tell them that I work for them. And because I tell them that I work for them, it changes a lot of things. It's not that they work for me. So whenever they call, I'm like 7-Eleven, I'm 24/7. I pick up the phone, and sometimes I don't know who's calling wherever I am. But the point is, this has opened the doors that are terrific. It's endless. And I even get so overwhelmed. I told you, I wish I can pack you all in a DHL bag so I'll bring you home with me to Asia.
So as an academic, I guess I'm in the business of coming up with new ideas and showing that they're feasible, that they're possible. And in order to be successful in that, you need to be very creative and innovative. And the flip side of that is that you can often feel like you just have insane ideas that are supported by no one, because by design, you're coming up with things that other people haven't gotten on board with yet. And so what I find gratifying about coming up with a new bioplastic, or in particular what I described in the beginning about our idea about living materials, making materials the way that biology makes materials, this was an idea that I was getting grants rejected one after another, for the last however many years. And but then my students, they are drinking the same Kool-Aid that I'm drinking, that this is a cool idea. And so they decided to submit this for this competition called the National Science Foundation Big Ideas Competition. And it's intended to kind of describe what we should be thinking about for the next decade. And their idea to make materials this way has kind of advanced through the ranks of this competition, and hopefully we'll make it to the end, I don't know. But seeing things like that where you see a glimmer of validation for a crazy idea that you had early on, I find to be something that keeps me motivated, and it gives you a little bit of confidence that the next crazy idea that you have has some value as well.
And I guess on my end, one of the big successes that have gotten me just super excited about this space. When I was in Australia, I remember I was on a dock in Mooloolaba, which was a hard name to actually say or spell. So I was on this dock and I was installing a bin to catch trash, and it's actually really mesmerizing to watch trash that's in the water fall into a little bin that's in the water. And these three groups or these three individual elementary aged children walk up, and they just get on their hands and knees, and they're just staring at the water, watching just tons of trash just fall into this bin. And they sat there for 15 minutes asking us, what is that? Why is it in the water? How did it get there? And hearing that little spark of inspiration from children and watching them walk away and yell at their parents for not picking up a piece of trash is what gets me excited about future generations and about how we can fix this massive problem that we're at. And so with that, I do see that we are at time. So I want to thank all of our panelists for coming up here and speaking with us. It's been absolutely amazing. So thank you.
Thank you.